Hi, and welcome to a stats project by Luke and Alec and Stephanie that we're doing. It's a bit late, and I'm in my kitchen, and I'm eating some cookies, so apologies in advance, but I think this is going to be a good presentation. Also, I don't know how to cut, so I'm doing this all in one take. Okay. So our project was to look at the relationship between literacy rate and access to water. The idea behind this was that in many developing countries, most of these things are limited. So by looking at how they are related, we can see how by increasing one, like access to water, we can also increase the education of people around the globe. And our prediction was obviously that as literacy rate increases, so will access to water. We gathered our data by looking at some different sites. We had data from PBS about how literacy rates are, and that's a percentage. Like, literacy rate is percent of the population that can read. And from World Bank, we got data on access to water, and that's just percentage of the population that has access to drinkable water. The way we did it was we took the big list, and then we just picked 49 different countries. And this may be a possible error in our experiment, but we didn't pick truly randomly. We tried to get a spread of countries with different wealth, and if we had had more time, probably the best way to do this would be to do a stratified random sample using the gross domestic product of each country. But we just try to get a good spread of different regions and different economic prosperities in these different countries to try and eliminate the effects of confounding variables. I'll talk more about that later, though. We took our data, we graphed it, and we created a least squares linear regression line. You have the equation here. Again, literacy rate and access are both in percentages. So our line, you see our R-squared value is 60.1, which is not great. Probably, I'm guessing, a line isn't the correct relationship, and it's not perfectly linear. I'm thinking, thinking about the issue, it might be linear, or not linear, a natural log, but, whatever. With that data, here are some observations first, because we had a couple points that did not really fit the line. They were sort of outliers, and that's maybe because the country has an extenuating circumstance, like nobody in the country can read, or the country is in the middle of the desert, so they have no access to water. Here, this is a scatter plot, and you see positive correlation, which supports, the line we created. Some other graphs, you see residuals. They definitely have a structure, and they are not, well, I don't know a particular structure, but they're not equivariant. And you see that on the residuals versus fitted values. And, yeah. And you also see below that on residuals versus the order of the data, that the residual increases as the observation order increases. So, maybe a natural log model would be better. So we did a regression analysis test. Linear regression slope test to see the probability that the slope is equal to 0. And the p-value of the slope equaling 0 was almost 0, which tells us that there's definitely a correlation. Well, actually, so we did, the slope is greater than 0, so this tells us there's a positive correlation between our two variables. Okay. And, from our line equation, we get that for every percentage point that average access to water increases, the literacy rate increases by 0.64163. So the second test we did was a 2-sample t-test, and you see this is sort of the data for it. And you think a 2-sample t-test might not really make sense at first because we don't really have matched pairs, but it makes more sense if you think about it as we're testing how well of an indicator access to water is of the literacy rate. So it's testing how good of a predictor that access to water is. And just think about it that way. So we did it with the difference. It was testing the differences, and because they're both percentages, actually that's why we can do this test. Because they're both in terms of percentages, we can do the mean. So the mean difference, sorry. The mean of the differences. And here we graph them, and you see because there's both significant overlap between them, and although average access to water is higher, so more people have access to water than can read, it's not a huge difference, and there like significant overlap between them. And since 0 is, we also constructed a 95% confidence interval on the difference is, and 0 was within that interval, which means that there's there's not a 95% chance. It just means that that 0 is within the realm of possibility. That 95% chance thing is wrong. I don't know who put that in. In conclusion, there is a positive correlation. Our data suggests that there is, on a significant level, 95% to be exact. There is a difference. There is a positive correlation. And therefore, in order for people to increase the literacy rate, people need access to water. So, books are no use if you're dying of thirst. And a little bit of wrap up. Access to water was measured. They weren't able to get data from every country, so we don't know how accurate the data is also. And again, it might be biased. Maybe researchers were only able to access certain countries, and countries may have changed their values to try and show that more people could get water. If we ran the test again, one thing we could do is divide countries into 2 groups: those with high access to clean water and those with low access. So I guess maybe coastal countries, we assume that they have more, or countries bordering lakes, maybe they have more access to water, I guess is what was written here. And actually, a better idea would be to do a stratified random sample for our data collection and try and get different domestic prosperities. Maybe that would help control for the effect of, economic prosperity on the literacy rate. So, how about that? Well, thanks for watching, and have a good night.